Dear students, let's continue our discussion on limits. Let's have a look at question 23. So here we have limit extends to a step x does not exist, does not exist if, when it does not exist, when a is an integer, a is a positive integer, a is a negative integer, a is not an integer. Okay. See, they have already given that this limit does not exist. So let's have a look at the graph of step x. Step x is nothing but the greatest integer function. Greatest integer function is defined as the greatest integer less than or equal to x. As we know, the graph of this, at 0 it is 0, from 0 to 1 it is 0, at 1 when x is equal to 1, step x is equal to 1, from 1 to 2 it is 1, at 2 it will be equal to 2, from 2 to 3 it is 2, from at 3 it is equal to 3. Okay. This is the graph of step x. And to the left side of 0 what happens? At minus 1 it is minus 1. Okay. This is the graph of step x. As you can observe, when the limit does not exist, at say for example 1 if I take, at 1 the left hand limit will be 0 and right hand limit will be 1. So left hand limit is not equal to right hand limit, hence the limit does not exist. Then at x equal to 2, at x equal to 3, at x equal to 4, you can observe not just for positive integers, even if you take the negative integers minus 1, minus 2, minus 3, etc. For example, at minus 1, as you can observe, left hand limit will be equal to minus 2 and right hand limit will be equal to minus 1. Okay. So we observe that at all integers this limit does not exist. So this limit does not exist whenever a is an integer, be it positive integer or be it negative integer. Therefore, the answer is any integer, which is the first option. And when a is not an integer, what happens? When a is not an integer, for example, if I take 1.5, at 1.5, let us see what happens. For the left hand limit, when x approaches 1.5, when I write 1.5 minus, its meaning is that x is approaching 1.5 from left side. When x approaches 1.5 from left side, means x is very close to 1.5 but less than 1.5, which means x may take the values 1.45, 1.48, 1.49, 1.499, etc. At all those points, step x value will be equal to 1. Then, if I write limit extends to 1.5 plus, that means x is approaching 1.5 from right side. X is very close to 1.5 but greater than 1.5. So it may take values 1.55, 1.53, 1.52, 1.51, 1.5001, etc. At all those points, step x value will be equal to 1. So left hand limit is 1, right hand limit is 1, therefore limit exists. So for step x, limit exists whenever x is not approaching an integer. If x is approaching an integer, when x tends to a, if a is an integer, then limit does not exist. When a is not an integer, then limit does exist. Okay. Then 24th question. If 7 minus x square by 12 less than or equal to f of x, less than or equal to 7 plus x cube by 5 for all x not equal to 0, then what happens to limit extends to 0 f of x? So they have given this inequality, 7 minus x square by 12 is less than or equal to f of x. That is less than or equal to 7 plus x cube by 5. Okay. See, given that f of x is greater than or equal to this expression but less than or equal to this expression. Okay. So now we can use sandwich theorem here. What does sandwich theorem say? If f of x is less than or equal to g of x less than or equal to h of x, then we can write limit extends to a f of x is less than or equal to limit extends to a g of x, and that is less than or equal to limit extends to a h of x. Okay, so I am applying limit here for this. So I will apply the limit as extends to 0 because that is what we need. Limit extends to 0 f of x. So limit extends to 0, 7 minus x square by 12 less than or equal to limit extends to 0 f of x that is less than or equal to limit extends to 0 7 plus x cube by 5. Okay, apply the limit as extends to 0. What happens here? 7 minus 0 by 2, that is 0, so 7 here, less than or equal to limit extends to 0 f of x that is less than or equal to, what happens here? 7 plus 0 by 5, 0 by 5 is 0, 7 plus 0 is 7. Observe this limit extends to 0 f of x is greater than or equal to 7, at the same time it is less than or equal to 7. This implies that limit extends to 0 f of x must be equal to 7. Equal to 7, third option is the correct answer. Then 26th question. Limit extends to 1 by root 2 x minus cos sin inverse x divided by 1 minus tan sin inverse x is equal. Okay, let us apply the limit directly. If I directly apply the limit, let's see what happens. 1 by root 2 minus, I am putting x as 1 by root 2 here. Here we get sin inverse 1 by root 2. What is the value of sin inverse 1 by root 2? Sin inverse 1 by root 2 is equal to pi by 4. Then cos pi by 4. Cos pi by 4 is 1 by root 2. Denominator 1 minus tan of sin inverse x. Sin inverse x. In place of x I am putting 1 by root 2. Sin inverse 1 by root 2 is pi by 4. Tan pi by 4 is 1. 1 minus 1. So numerator is 0, denominator is also 0. So when you get to 0 by 0, we are very happy, right? So what do we do then? We will go for L-Hospital's differentiate this. Limit extends to 1 by root 2. Differentiate, derivative of 1 is 0. Sorry, derivative of x is 1 minus cos sin inverse x is there. Its derivative. It's like cos x. Derivative of cos x is minus sin x. So derivative of cos sin x is minus implies plus sin of sin inverse x into the derivative of sin inverse x. What is the derivative of sin inverse x? 1 by root of 1 minus x square divided by derivative of 1 is 0 minus derivative of tan sin inverse x. Derivative of tan sin inverse x. Derivative of tan x is secant square x. So derivative of tan sin inverse x is secant square sin inverse x. Secant square sin inverse x into the derivative of sin inverse x. Derivative of sin inverse x is 1 by root of 1 minus x square. Derivative of sin inverse x is 1 by root of 1 minus x square. Okay. Now let's put x, let's apply the limit. That means putting x as 1 by root 2. Okay. 1 plus. Here, sin of sin inverse x is nothing but x. So when I put x as 1 by root 2, this is 1 by root 2 into 1 by root of 1 minus x square. X is 1 by root 2. So x square will be 1 by 2 divided by minus secant square sin inverse x. So x is 1 by root 2. So sin inverse x is sin inverse 1 by root 2. That is pi by 4 into 1 by root of 1 minus x square. I am putting x as 1 by root 2. So x square will become 1 by 2. That's equal to 1 minus 1 by 2. That is 1 by 2. So you get 1 root of 1 by 1 by root 2. This 1 by root 2, 1 by root 2 gets cancelled. You will have 1 plus 1 divided by minus of secant square pi by 4. What is the value of secant pi by 4? Secant pi by 4 is root 2. So secant square pi by 4. 2 into 1 minus 1 by root 2. What's the value of 1 minus 1 by root 2? 1 minus 1 by 2 is 1 by 2. So we get 1 by root 2. Okay, that's equal to 2 divided by minus 2 root 2. 2 gets cancelled. Answer is minus 1 by root 2. Minus 1 by root 2, which is the second option. Then 27th question. limit extends to 0 sin 3x tan 4x divided by x into sin 5x. Now, here if I directly apply the limit, here also I am going to get a 0 by 0. We can use L-Hospital's rule, but for this problem, using L-Hospital's rule is not advised. Why it is not advisable? Because in the numerator it is a product of two functions, sin 3x tan 4x. So you have to use product rule there while differentiating. Denominator also same thing. Product of two functions, you have to use product rule, it takes more time. Okay. Say, we know limit extends to 0 sin x by x equal to 1, right? So I do it in this. Limit extends to 0 sin 3x by x into limit extends to 0 tan 4x by sin 5x. This expression can be written as 3 and this expression can be written as 4 by 5. So answer is 12 by 5. Fourth option. Did you understand? No? Okay. I'll explain in detail. Okay. Say, I do it in this way. Sin 3x is there. I want 3x in the denominator. So multiply and divide by 3. Okay? X is there. I am writing 3x. So I have multiplied and divided by 3. Then tan 4x is there. I will do it in this way. Tan 4x by 4x into 4x. Okay? I have multiplied and divided by 4x into 1 by sin 5x is there. So sin 5x divided by 5x into 5x. Okay? I have multiplied and divided by 5x. Now as x equals to 0, sin 3x by 3x becomes 1. Tan 4x by 4x becomes 1. Sin 5x by 5x becomes 1. Right? And after that, this x gets cancelled. Before applying the limit, okay? X gets cancelled. And after applying the limit, these all become 1. So what is left now? 3 into 4 divided by 5. 3 into 4 is 12 divided by 5. That's that. 12 by 5. Okay. Now, actually, by looking at it only, you can identify this is equal to 3 here into 4 here divided by 1 into 5. 12 by 5. Look at the coefficient of x here, 3. Here the coefficient of x is 4. Here 1. Here 5. So answer is 3 into 4 divided by 1 into 5. Directly the answer. Did you understand? Okay. So see in our synopsis, the same thing they have given in another form. That is, if I did not explain that during our synopsis discussion because there are quite a few formulas. Remembering all of them may be a difficult. But while solving this problem, there are, without knowing that formula also directly you can answer in this way. There, what they have given is that S is equal to, S is the center, consisting of x, sin x, tan x, sin inverse x, tan x. Okay? Then, if we have, and wait, let f1 of x, f2 of x, g1 of x, g2 of x. All of these belong to S. These four functions, f1, f2, g1 and g2, there are some element from this set. There are some functions from this set. Then we can write it, limit extends to 0. f1 of mx into f2 of nx divided by g1 of px into g2 of qx. Can be written as mn by pq. That's what they mentioned. If these functions f1, f2, g1, g2, they are either x, sin x, tan x, or tan inverse x, or sin inverse x, then limit extends to 0, f1 of mx into f2 of nx divided by g1 of px into g2 of qx is equal to mn by pq. This is the formula that I have given. Okay. But maybe I think it's a touch difficult for you to remember. This logic you can easily remember. Remember, this is applicable only when you have sin, tan, x, sin inverse x, cos, tan inverse x. Instead of one of this sin, if cos appears, this formula cannot be used. So instead of sin 5x, suppose if we have cos 5x here, then the answer is 0. How? How I check? Say, now what do we do? Limit extends to 0, sin 3x is there. I want 3x in the denominator, so 3x into 3. Then tan 4x I have, so I want 4x in the denominator into 4x. Denominator cos 5x is there, so for this you don't have to divide by 5x because directly if you apply x as 0, cos 0 you will get 1. Now this is 1, but 3 into 4, 12x by cos 5x you have. Limit extends to 0. When I apply the limit as extends to 0, numerator is 0, denominator is 1. 0 by 1 is equal to 0. So earlier formula I told you that in this we can directly write this as 3 into 4 divided by 1 into 5. That is possible only if all of these functions are either x, sin x, tan x, sin inverse x and tan x. If they are from that set, then only you can write it in this way. Okay? You'll understand better when you solve some more problems. Let's go to the next one. Limit extends to 0, 1 minus cos x by x into log 1 plus x is equal to. Limit extends to 0, 1 minus cos x divided by x into log 1 plus x. Now, here in the denominator, I will divide by x. Log 1 plus x is there now. I am dividing by x. Here already one x is there. I am dividing by x. So, to compensate that, I have to multiply by x. So, it will become x squared. Okay. The reason why I have done this is because I know one formula. I wish that you must also know this formula. That is, limit extends to 0, log 1 plus x by x is equal to 1. This formula you should know. See, if I directly apply limit here, log 1 is 0, denominator 0, 0 by 0 and indeterminate form. So, if I use L-Hospital's rule, I am getting 1 by 1 plus x divided by 1, apply the limit, you will get 1. Okay? But this is standard result, you should remember. Now, I have multiplied and divided by x so that this will become 1 as x approaches 0. So, 1, you need not write to the next step now because 1 into whatever you get, that whatever will be the answer, right? So, limit extends to 0, 1 minus cos x divided by x square. Okay? Now you apply the limit. See what happens. Numerator. If I apply the limit directly, cos 0, 1. 1 minus 1, 0. Numerator is 0, denominator also 0. Now you go for L-Hospital. See, you might ask me, sir, initially also we could have gone for L-Hospital. So, yes, we could have. But then it takes 2 or 3 more steps because you have to differentiate x into log 1 plus x. You have to use product rule. X into derivative log 1 plus x means 1 by 1 plus x plus log 1 plus x into 1, etc. It takes more time. So, I have asked you to multiply and divide by x. Now, I will use L-Hospital. Derivative of 1 minus cos x will be sin x. Derivative of x square. This is right. Derivative of x square is 2x. Now, as x approaches 0, sin x by x becomes 1. And the answer will be 1 by 2. 1 by 2, which is the fourth option. Okay, next. 29th question. Limit extends to 0, tan x minus sin x divided by x cube is equal. Tan x minus sin x divided by x cube. Okay. So now, if I directly apply the limit, I am getting tan 0, that is 0, minus sin 0 is also 0, divided by 0, 0 by 0, an indeterminate form. But, you can use L-Hospital's rule, but not advisable in this problem. Why it is not advisable? Because you just have a look at the denominator, x cube is there. Once if I differentiate, I am getting 3x squared. Then also while putting x as 0, it will be 0. After that again you have to use L-Hospital. Then it will become 6x, right? Once if I differentiate, you just concentrate on the denominator. Okay, I come to numerator afterwards. Just concentrate on the denominator. When I directly substitute x as 0, denominator is becoming 0. So when we use L-Hospital rule, that is when we differentiate, we get 3x squared. Then also when I put x as 0, it becomes 0. So I will again go for L hospital rule. Then after differentiating, you get 6x. So at that time also it becomes 0. So you have to use L hospital rule again. Okay. Then the derivative 6x will give you 6. Okay. That means you will have to use L hospital rule thrice to get the answer. Right? But differentiating the denominator thrice is okay. Differentiating derivative x cube is 3x square, then 6x, then 6. You will do it easily. That's all. But just have a look at the numerator now. Once if I differentiate, I am going to get secant square x minus cos x. Okay. Again, if I ask you to differentiate that secant square x minus cos x, then what happens? 2 secant x into secant x tan x plus sin x. Okay. Then if I use if I directly apply s, it is becoming 0 because I have 2 secant square x into tan x plus sin x. Again, if I ask you to differentiate it, you will have to use product rule. 2 into derivative secant square x tan x becomes secant square x into secant square x plus tan x into 2 secant x into secant x tan x plus cos x. So it will take more time and more space also. So we shall think of something else now instead of going L hospital's rule. See, L hospital's rule can be used, but the whole purpose of using L hospital's rule is to get the answer quickly. How quickly we can reach the correct answer, that is important. But though we can use L hospital's rule for this problem, but I don't think we can. This word is enough to if I use L hospital's rule. It will take more time, but hence I will give you another for this problem. Okay. See now, in the numerator, I take tan x as common. You might be wondering, sir, where is tan x? Here tan x is there, so it will come on. And what happens here? I directly write that as cos x. There x. That x cube I will write as x into x cube. Okay? X cube I wrote it as x into x square. I know your doubt is not about what x and x square. Your doubt is about how did we get to that cos x, right? So what I did is, you just concentrate on the numerator. I took tan x as common. Then you will have 1 minus sin x by tan x. Right? I'm just writing the numerator only. Tan x into this tan x I will write as sin x by cos x. Then sin x is cancelled. That 1 by cos x will go to the numerator. You end up getting 1 minus cos x. Okay, that 1 minus cos x only. Did you understand? Okay. Now, in the next step, I will group this. Tan x by x becomes 1 as x approaches 0. So we are left with limit x tends to 0, 1 minus cos x divided by x square. Limit x tends to 0, 1 minus cos x divided by x square. This is equal to 1 by 2. Already we saw in the last problem. Okay, if you don't know, also not an issue. If I directly apply limit now, cos 0 is 1, 1 minus 1 0, denominator also 0. So use L hospital's rule. This will give you sin x by 2x. Sin x by x is 1, so answer is 1 by 2. Second option. Is it clear? Now I advise you to remember this formula. Limit x tends to 0, 1 minus cos x by x square equal to 1 by 2. That is true. Okay. Then 30%. Limit x tends to 0, 1 minus cos 2x degree divided by x square. See here, one of them is in degrees, other one is in radians. In such cases, I advise you to convert that degree into radians. Okay, before applying the limit. And before that, I will use this formula. It looks like 1 minus cos 2 theta. 1 minus cos 2 theta can be written as 2 sin square theta. Okay, 2 sin square theta. So it will become 2 sin square x divided by x square. Okay. Now I will convert this x degree into radians. When I write x degree in terms of radians, it will become pi x by 180 divided by x square. Sin square by x by 180 divided by x square. Okay. Now there is sin square by x by 180 in the numerator. What do you prefer in the denominator? In the denominator, we prefer, if you have sin square x, we want x square in the denominator. Now we have sin square pi x by 180, so we want pi x by 180 in the denominator. So I will write it in here. Limit x tends to 0, 2 into sin square pi x by 180. In the denominator already there is x, so I will write as pi x by 180 whole square into pi by 180 whole square. Okay, so I have multiplied and divided by 180 whole square. Now as x approaches 0, this factor becomes 1. Because when x tends to 0, pi x by 180 will also tend to 0. So this will become 1. Answer is 2 into pi by 180 whole square. 2 into pi by 180 whole square, which is the fourth option. Then 33rd question. Limit x tends to 0, sin of pi cos square x by x square. Limit x tends to 0, sin of pi cos square x divided by x square. Now, some students will make one mistake. That mistake is, see, when you have sin theta in the numerator, we want theta in the denominator. So when you have pi cos square, sin of pi cos square x in the numerator, you prefer pi cos square x multiplied and divided by pi cos square x. Then as x tends to 0, this tends to 1. That is right. That is not correct. Why it is not correct? Because when x tends to 0, this expression should tend to 0. Pi cos square x, say we have sin theta by theta, this is equal to 1, provided we have theta tends to 0. Here, when we say multiply and divide by 2, suppose if I have sin 2x by x, what do? I will multiply and divide by 2, because here sin 2x is there, we want 2x in the denominator. Okay? But here, sin pi cos square x is there in the numerator, therefore I will divide by pi cos square x in the denominator. Therefore, we want that and we cannot write this as 1. Why? Because in this case, we can write this as 1. Because now, when x approaches 0, this 2x is also approaching 0. Whereas, in this particular problem, when x approaches 0, pi into cos square x does not approach 0. Because pi into cos square x, cos square 0, cos square 0 is 1. So, pi into cos square x is approaching pi, not 0. When x approaches 0, pi cos square x is approaching pi, not 0. Therefore, you cannot write this as 1. We can write a sin theta by theta as 1 only when theta is approaching 0. In this problem, when x approaches 0, 2x also approaches 0, not a problem. Okay. I will give you one more example. Instead of sin pi cos square x, if you had a sin pi sin square x, if you have something like this, now you can multiply and divide by pi sin square x. Pi sin square x into pi sin square x. Now this expression becomes 1, because when x approaches 0, sin square x will also approach 0. So pi into 0 will, this factor, when x approaches 0, this factor approaches 0. Therefore, the value of this limit will be equal to 1. Whereas here, when x approaches 0, pi cos square x does not approach 0. Therefore, the value of this limit is not equal to 1. Did you understand? Okay. Now, coming back to this problem. So, multiplying and dividing by pi cos square x will not work here. Then what else will work? Let us see. Can I use L-04 rule? If I directly apply the limit as x tends to 0, cos square 0 is 1. Pi into 1 is pi. Sin pi 0. Denominator also 0. 0 by 0 and indeterminate form. So now if I differentiate cos pi cos square x into pi into the derivative of cos square x, which is 2 cos x into minus sin x divided by 2x. This 2 I will cancel, and as x approaches 0, this sin x by x becomes 1. As x approaches 0, sin x by x becomes 1. Okay, we are left with 1. Now apply the limit. Cos square 0, it is 1. So you have cos pi into pi into cos 0, that is 1, into minus 1. Cos x sin x by x becomes 1. What is the value of cos pi? Minus 1 into pi into 1 into minus 1 is minus 1. So the answer is pi. Second option. Okay. Let's have a look at the next question. 35th question. Limit x tends to 0, 1 minus cos mx divided by 1 minus cos nx. Here, if we directly apply the limit, I am getting cos 0, 1 minus cos 0, 1 minus 1, 0, denominator also 1 minus 1, 0, 0 by 0. So you can use L-04 rule. Derivative of 1 minus cos 1 is 0, derivative of minus cos mx is sin mx into a. Derivative of 1 minus cos mx is sin mx into a. Now as x approaches 0, sin mx by sin nx will give you m by n into m by n. So the answer is m square by n square. You can remember this as a formula. Okay, this is equal to m square by n square. In this way you can do it, or else you can do it by using 1 minus cos theta form also. 1 minus cos theta can be written as 2 sin square theta by 2. So this will become 2 sin square mx by 2. Denominator will become 2 sin square nx by 2. 2 gets cancelled. Sin square mx by 2 divided by sin square mx by 2. This will become m square by 4 divided by n square by 4. 4 gets cancelled. M square by n square is the right answer. Okay. Next. 37th question. Limit x tends to 0, 1 minus cos 2x into sin 5x. X tends to 0, 1 minus cos 2x into sin 5x divided by x square into sin 3x. Say as soon as you see this sin 5x by sin 3x, you can directly write that as 5 by 3. Then what happens to 1 minus cos 2x? 1 minus cos 2x I can write as 2 sin square x divided by x square. Sin square x by x square becomes 1 into 5 by 3. Answer is 10 by 3. First option. Then 38th question. Limit x tends to 0, sin of x power n divided by sin x of whole power n. M and n are natural numbers. This must be equal to 0 if m greater than n, n greater than m, m is equal to n always. Sorry. Limit x tends to 0, sin x power n divided by sin x whole power n. Sin x power n by sin x whole power n. Okay. Now I'll verify by taking some examples. Okay. First I'll take m is equal to 2, n is equal to 3. I'm verifying m greater than n at sorry, m is equal to n equal to 3. So m less than n I'm considering, which means I'm considering third option. Sin of x cube divided by sin x whole square. That's equal. So sin x cube means I want x cube in the denominator. Multiplied divided by x. Sin x whole square is nothing but sin square x by x square into x square. As x approaches 0, this will become 1, this will also become 1. Here x square gets cancelled, x will remain. As x approaches 0, this x will be equal to 0. That's what we want. M is less than n. Okay, so third option is the correct answer. You can reverse it also. Suppose if I take m is equal to 3 and n equal to 2, the rest you want. sin n x power n sin x square divided by sin x square. That's equal to limit x tends to 0 sin x square by x square into x square divided by sin x whole cube means sin cube x square divided by x cube into x cube. As x approaches 0, these two will become 1. X square by x cube means 1 by x will remain. As a limit x tends to 0, 1 by x limit does not exist. So that cannot be the answer. And if m is equal to n, let me take m is equal to 2, n equal to 2. I take m is equal to n equal to 2. Then what happens? Sin x square by sin x whole square. That's equal to limit x tends to 0 sin x square. I want x square then into x square. Divided by sin x whole square is nothing but sin square x by x square into x square. As x approaches 0, this is 1, x square gets cancelled, answer is 1. Okay, when m is equal to n, answer will be equal to 1. So therefore, it is true when n is greater than m. If the degree of the numerator, that sin x power n, here sin x whole power m, if n is greater than m, then this expression, this limit will be equal to 0. Okay, students, with this problem I will stop today's class and continue the next class. Thank you.